Hey, this is Mike Landers. I'm going to be explaining my CS-575 software design, Project 3, which was a simple 3D game developed using the Unity 3D platform. I've only got 5 minutes for this video, and there are way more points I could talk to regarding Unity in 5 minutes, so I'm going to try to basically summarize this project by giving an overview of Unity, an overview of MonoDevelop, which is the associated IDE where I can talk about the C# code I've written, as well as the architecture of my project. Finally, we're going to do a demo of the game on an emulated Android device. So a quick overview of Unity. Unity is composed of a 3D and 2D game engine, has a built-in IDE called MonoDevelop, which I'm showing right here briefly, and a GUI-based scene editor. So now we're going to do a really brief overview of Unity, which is the window I've got open now. What we're looking at here is called the scene editor, which is a GUI-based scene creation tool. You can also demo your game, which is really useful. The hierarchy of the components in my game are all listed over here. Most of them don't have a whole lot going on except for the player object, which is the marble. I've got 2 C# scripts attached to the player object. I've got a bunch of special effects attached to it, physics, rigid body, mesh renderer for colors and textures. The other major component in the system is the main camera, which if I zoom out, you can actually see here, and you can see the field of view is shown. So I have a script attached to the camera which dynamically adjusts the field of view, the position and rotation information. Now I'm going to talk briefly about the C# code that I developed using MonoDevelop, which is Unity's IDE that we see here. So I've got 4 scripts controlling dynamic content generation within the game. I just talked about the camera controller a bit, which is utilized to control the camera and all of its associated properties, which affects what the user sees and gives the game a 3D feel. Also optimizes the player's viewing area on their screen, which I found is important. Maze generator, which of course is the maze generation algorithm. It's possible to generate a maze using several different graph traversal algorithms, Kruskal, Prim. I've used depth first search. The primary purpose of my player controller C# code is to translate the input from a device into movement of the player object, so swiping or accelerometer input. Additionally, the player controller is responsible for picking up player-driven events such as collisions. I have several different types of collisions which can occur with different types of objects, and as you can see, one of them kicks off the maze generation as a coroutine. The use of a coroutine is important for both Android and Apple platforms because apps only run using a single thread. So if you do something processor intensive, such as maze generation, the game is going to freeze while the algorithm runs. So what a coroutine allows you to do is to yield at certain points within the specified function, allowing frames to be drawn while the function runs, which allows the user to see the maze being generated real time, which I actually think is pretty cool. So now we're going to build the game and run a quick demo on an emulated Android device. The virtual device simulator that I'm using is called Genymotion. Alright, so the device is up and running. So at this point we're going to kick off a build and run it on the device, which for Android is a matter of generating an APK, which is an Android app package, and it gets uploaded through Unity to the virtual device that I've got open. So now we're going to run a quick demo of the game on this emulated Google Nexus 7 Unity splash screen. And here we are. I personally prefer landscape mode. This is a tool that's associated with the emulator. While I'm demoing the game, I just wanted to talk to a few last points, including the architecture. Clearly, this utilizes the model view controller design pattern, where the view is a GUI. The model is the software state, including all the data and logic that's saved behind the scene. And the controller is the user input, which includes the accelerometer and keyboard or swiping input from a user. Additionally, this type of game utilizes an event-driven architecture, as everything that happens in the game is a direct result of user-generated events. So that's it. Thanks for a good quarter.